left off yesterday, and I think this is where your class yesterday as well, introducing the idea of the horizontal and vertical components and the linear combination. So how we can take a vector from component form and put it in a linear combination form of a times I plus b times j. We're talking about how a can be the horizontal component of the magnitude times cosine theta, and b can be the vertical component of the magnitude times sine theta. And we were getting ready to go into example 4 here, where we start talking using those components and using our direction angle. So, example 4, find the components of the vector v with a direction angle of 115 degrees and a magnitude of 6. So, first of all, realize when they say find the components, they're asking us to find A and B. Okay? They're asking us to find A and B, so whether it's the vector and it's A comma B, or whether it's in linear combination of A times I plus B times J. So we're being asked to find the components. Direction angle of 115 degrees. What's that going to represent? In our formula, that's going to be what? Go back and read. Where did it talk about the direction angle of a vector is the angle what? Just right up above.
Angle theta.
Angle theta. So direction angle is going to be 115 degrees, and that's going to represent theta. Okay? And if you go back and read from yesterday, it says it's the angle that the vector makes with the positive side of the x-axis. Well, where does 115 start? I'm going to erase this here in a moment, but 115 starts where? Right here, positive side of the x-axis, and goes over there, right? So that is that whole piece is your theta there. And a magnitude of 6. Thoughts on that one? What is magnitude? The what? The length. And what do we use to represent magnitude, length? What do we use to represent that?
V.
Not just V.
Absolute value of V.
Absolute value of V. Okay? Anytime they start talking about magnitude or length of a vector, you're thinking the absolute value of that vector. Okay, so do we have some formulas we can use here?
Do we have to find the linear combination?
Well, don't think about linear combination right now. Just think about finding the components, finding A and B. Do we have formulas? Here's my hint, guys. Go back and reread that paragraph that I was just reading to you guys right as I start today's lesson.
Yes, we have V equals that big long thing. Cosine of theta. 6 times sine of 115 equals B.
Okay, because so what formula are you pulling there?
The vertical component of the vector.
Okay, the vertical component,
And
B.
the horizontal component.
Okay. So vertical component, B, it says B is absolute value of V times sine of theta. So that's how we'll find our B. How are we going to find our A? A is absolute value of V times cosine theta. Come on, guys, help me out. You can read. You didn't make it this far without reading. So we're going to use those two formulas. When they give you a direction angle and a magnitude, that's always what you're going to have to use. So those are my formulas. Let's fill them in. In order to find component A, what am I putting in for the absolute value of V?
6.
6 times cosine of 115 degrees. We'll go ahead and fill in B while we're here, and then we'll do some actual math. Magnitude, or absolute value of V, again, is 6. This time it's going to be sine of 115 degrees. Okay, we're not going to leave that. We are going to keep going. And I mean, if you take a brief moment and think about 115, And, you know, my brain starts to think, oh, how far is 115 from 180? But 115 from 180 is what? 65? Is that one of our reference angles?
No.
No. If it was 30, 45, or 60, I could use my chart, right? It's not one of my reference angles, so we are going to the no
Calculator.
calculator. It's not one of my reference angles, so I can't go to the unit circle. I have to go to the calculator. Okay? So what is 6 times the cosine of 115 degrees?
-2.5.
Okay. I have 2 decimal places written down. -2.5.
Is it going to say 2 decimal places?
I know, that's what I'm looking back at my notes to check. I have it 2 decimal places all throughout this entire example.
Good.
Okay? Is that? You never know. Okay, what about B?
5.4.
Okay. 6 times the sine of 115 degrees should be, what do we say, 5.44? Now, right there, we have technically answered the questions because it said find the components of the vector V. And the components are A and B. Now, we're going to write our answer in 2 different forms for practice here. One, we're going to write it in component form. What does this look like in component form?
-2.54, comma 5.44 with the little V's on the sideways V's.
Okay. I'll take that description. So vector notation is what looks like the less than greater than arrows that are acting as parentheses, right? -2.54, comma 5.44. And so that is our component form using A and B there. And then we're also going to use this example, and I believe if I recall correctly, homework asks you to do both, component form and linear combination. What is this written as a linear combination? Okay, so it's the A component times I plus the B component times J. So ours ends up as what? You guys are all writing it without me, aren't you? Okay. At least you're not all staring at me, waiting for me to write it. What are you writing?
-2.54i plus 5.44.
There you go. Thank you.
Took me a second.
I'm annoyed that they use J because now it just looks like an I. The J that's backwards, which is my I, because I'm just so annoyed at this.
Gotta find a different way to write it.
Ooh.
Okay. So, when I ask you to find components, you're looking for A and B. I believe it asks you for component form and linear combination form, and we have demonstrated both of those forms. Okay? Okay. Example 5. Ask us to find the magnitude and the direction angle of each vector. Magnitude and direction angle of each vector. And example A is the vector 3, 2. So let's start by talking about magnitude. What do you know?
I don't know if this is helping find magnitude, but you know that 3 is A.
It's valid information that it'll be helpful to talk about at some point. So, okay. Our components are A and B there. How did we find magnitude yesterday?
The square root of v1 squared plus v2 squared.
And that's V1, V2 right there.
Right, and those are V1. Well, we just called them A and B because they are the horizontal and vertical components, which we're going to, we are going to refer to them as A and B. That's the same thing as saying the V1 and the V2. Okay, V1 being the first component, V2 being the second component. So we're using that formula for absolute value. I'm going to say absolute value of U because they're calling it vector U right here. And so in order to do our absolute value of U or our magnitude, square root of 3 squared plus 2 squared. What is it?
Square root of 13.
Square root of 13. And generally speaking, we usually leave it as that radical. I say always, but usually. And that's yes. So this is our magnitude. What else are we asked to find? The direction angle. So what is it I'm looking for?
What is
Theta.
Yeah, we're looking for theta. So we need a formula or a way to find theta.
Well, we can use A or we can use B. Right?
Does that make sense? I agree. Does that make sense? So we can use A or we can use B? Okay. Emma had just pointed out that in our vector 3, 2, that those are, what did we call those? A and B. And if you go back, we have formulas for A and B, right? We have a formula for A, our horizontal component, and a formula for B, our vertical component. And I'm actually going to, so the idea is this vector could be written as, what do I want to say? Absolute value of u times cosine theta, and absolute value of u times sine theta, yes? Like based on our horizontal and vertical components up above, we can do that. Well, with that in mind, do we have numbers those equal? We do, okay? I think I'm going to set them up both, just to prove to you that it doesn't matter which one you use, that they're both going to work. They'll look a little different along the way, but they'll both work in the end. So, if I set this up, if we use the horizontal component, the A value, we're going to know the absolute value of u times the cosine of theta is going to equal 3. Except what is the absolute value of u?
Square root of 13.
Square root of 13. So I can say that the square root of 13 times the cosine of theta equals 3. That's one equation I could set up and solve to find theta. Or the other equation you could solve is we can use the sine theta piece, the vertical component. We can say absolute value of u, so that again is square root of 13 times sine of theta. That equals my vertical component of 2. This is an either or. This is not a you're required to do both type thing. Now, what? Say it again. Okay. We're trying to solve. We're trying to get cosine of theta by itself. So we are going to divide by the square root of 13 in both cases. One option is that cosine of theta equals 3 divided by square root of 13. The other option is that sine of theta is equal to 2 divided by the square root of 13. Okay, and then how do we solve? If we have cosine or sine theta, and we're trying to solve for theta, you've got to know that step by now, right? Okay, if you're trying to find that angle that's within there, you're not using sine and cosine, but you're using your inverses. Now, so you could do either cosine inverse of 3 square root of 13, or you could do sine inverse of 2 over square root of 13. Again, either or options here. What are we getting?
33.69.
Okay, and which one did you do, Hannah? You did both?
Yeah.
You got the same on both?
Yep.
Okay, good. And there's a reason I asked that. Okay, so we can feel pretty confident if we got the same thing on both that this is the correct answer, right? Here's what you need to get in the habit of checking. Okay, 33.69. This vector was listed as 3, 2. What do you know about that when you think about that as an ordered pair? Where is it?
That's in the
Quadrant 1.
yeah.
Okay. So my point I'm trying to get you to think about is, if this is in quadrant 1, where should my answer end up?
Quadrant 1.
Quadrant 1. Which it did, yes? So we're good there. Here's where you're going to run into problems. Okay? When it's supposed to be in another quadrant, it depends, because sine inverse will only find quadrant 1 and quadrant 4. Remember that right half of the, the output is only the right half of the unit circle. Cosine is only going to find quadrant 1 and 2, because it's only going to find the top half of the unit circle, if you remember those half circles we used. And so that's where you have to watch out there, that we were guaranteed to come up fine here because it was in quadrant 1. When you get outside of quadrant 1, you might have to do some adjustments to make it in the right quadrant. Okay? So questions on A? Okay. Let's try B. What you got here? Thoughts? Okay, starting off finding the magnitude, I assume? Okay. This is labeled as vector v, so I'm going to say I'm finding the absolute value of v this time. Square root of negative 2 squared plus negative 5 squared, which is going to be square root of 29, he says. So there's your magnitude, which one they asked us to find, but then two, you also learned last time that it is useful here, isn't it? Okay. Now what? If we have this form negative 2, negative 5, what are my options? Okay. In a vector, first component is the magnitude times cosine of theta. The second component is the magnitude times sine of theta. Okay. Pick one and see what you can do with it. Okay. Or we can try to remember how if they both come up the same in this one or not. I'm not sure they do. Okay. And Hannah's back there talking, what quadrant are we going to expect our answer to be in? Okay, so third quadrant. So tell me, while we're here, what would you expect your answer to be between if it's in quadrant 3? Agreed? If my answer is supposed to be quadrant 3, I'm looking for an answer that is somewhere between 180 and 270 degrees. If I get anything else, that doesn't mean I made a mistake. It just means I have to adjust the angle I was provided. Okay? So, with that in mind, do some math. You can pick to work one, that's fine. I think I might pick both here just to, I don't remember how they both come out, so. Okay, pick one and work one. So I can either say square root of 29 cosine theta is equal to negative 2. If that's the case, then what? Okay. Cosine of theta equals negative 2 over square root of 29. And that means, how do I find theta? And what am I putting in on my calculator? Cosine inverse of negative 2 over square root of 29. What's your calculator saying? 111.80. Is that my final answer? It cannot be my final answer. Does it mean I'm wrong? No. It just means we have to adjust because inverse trig functions are not always going to give us the right one. Did anyone work the sign out? I don't have it written in my notes. Does it work out to be the same?
You got negative 68. Did you get something different?
No, I was just trying to figure out, because this is the one I've written in my notes, so I was just trying to process how it would come out. No, I just don't have it written down. Excuse me. Okay, now, here's the deal, guys. Okay, if we do, okay, so, little side sketch here, right? So if I do a side sketch, where is 111.8 degrees? Quadrant 2, yes. Whoops. In quadrant 2, yes? Where am I supposed to be? In quadrant 3. So here's the deal. I need an angle that is, think reference angles here, I guess, essentially. I need the angle that is essentially across the x-axis from it. So what are options mathematically of how I could get that?
Plus 90. It only gets 1 to 179. Add 90 to it?
No. I don't think it does. No. No.
But it's negative, so that's not.
Okay, guys, think in terms of where it is in relation to things. So here we start at 0. We went this way, right? And got to 111.8 degrees. Okay. Keep in mind, this is 0, 90, 180, 270, 360, yes? I would not think in terms of adding something.
Do you go from the bottom?
Like 1.
I would think in terms of, I don't like how I drew that, going this way instead. And if I'm going that way, because I'm still going this equal distance, right? But how do I get there? What'd you say, Emma? Or not Emma, Natalie? Subtract from 360. Because where are you starting at right here? This is 360, yes? And if we're going backwards, you can think 360 minus 111.8. And I should have done that. Come back to my purple to do that, but ooh, not what. So we're looking here instead to figure this out. 360 minus 111.8, which is
240.2.
to what?
248.2.
Okay. Sorry, the yawn in the middle of the answer. I couldn't quite. It kind of like garbled it a little bit. And I was like, wait, what? Okay.
How do you do the other one?
So the other one you said,
Negative 68.19. Or 0.2.
oh wait, it's negative?
Yeah.
Yeah.
Does it? Okay, here's my thought. Double checking here before I say it. Yeah, okay. So the other one, let me pick, I don't know, just looking for something different here. The other one, if you went the sign direction, you got negative 68, right?
Yep.
And so negative 68.2. Okay. Now, I drew this without asking. Are you guys okay with why I drew negative 68.2 here? The negative angle takes us where?
Yeah.
Down. And so that is 68.2 degrees below the x-axis. We need the equivalent angle, but over in quadrant 3. In quadrant 3, then, you want the angle that is also that same amount down from the x-axis. Because remember, we're always talking reference angles. How far something is from the x-axis. Does that make sense? So in this case, how am I going to figure this one out if I'm trying to go with how far I am from the x-axis?
Subtracted from 180.
Because you're subtracting it from right here. And so if you do 180 minus 68.2,
You get 111.
You gotta subtract
Oh.
negative 68.2.
wait. Yeah. How about we not subtract? If you're at 180 here
If you add, you get
and you're going forward, you're going to add it. So you're going to take 180 and add 68.2.
But you're still gonna get like 111.
No, you're not. Not if you add.
it's 248.
Oh,
I'm not. Forget the negative.
Okay.
It's a distance. You have to ignore all negative positive signs and you have to think about, okay, how am I going to equivalate this? If this is 68.2 degrees below the x-axis, I need 68.2 degrees below the x-axis over here. So I just think of it as adding it. I guess you could think of it as subtracting a negative, but I just try and look at it logically. And I don't know, I heard subtract, I went with it, my brain got confused. Okay? So regardless, draw yourself a little picture, try and match it up. Okay. Have I made some sense of that?
Are we only doing one problem on 6.152?
We are, but here's what I think I'm going to do. Or at least I think that's all I'm doing. Let's go with, because it's one of those things. I can try and do the next problem, and then what's going to happen? We're either going to get through it, or we're going to get caught in the middle. And I'm afraid of getting caught in the middle. So, I'm going to stop here. What I want you guys to do for Monday is yesterday's assignment up through the 34.
Okay.
Now, on Monday, it's going to be kind of a multiple thing here, okay? I'm probably going to, at some point in the period, do that last example, which means probably for Tuesday you'll finish 41, 42, or you'll do them in class on Monday, 1 and 2. We'll probably try and check. Well, we'll see how things go, whether we check on Monday or wait. But do the bulk of the assignment. Obviously, don't worry about 41, 42 yet. Okay, so I will finish at least one note on Monday. Are we clear?
Yes.
Can I put the calculator?